Hello everybody, welcome to Marketing Analytics course. This is Dr. Shagata Chatterjee from VGSOM IIT Kharagpur who is taking this course for you. We are in the last phase of week 6 and in this particular video we will talk about media data. So, how to decide that in which kind of, so I have decided that okay, I have some ad expenditure and based on the marketing mix models and etc. I decided that okay, X amount of money will be spent on digital. Now, let us say or TV let us say, and there are lots of TV programs that is running up. As I told in the last video that TV programs you give 30 seconds ads and 20 seconds ads and etc. and there are certain rates, and as the popularity of that particular this thing goes up as the popularity of the particular program goes up, based on the popularity, based on the demographics, based on various other factors, they decide how much they will actually charge per second. So, those charges are there. Now, my problem is that I have been given X amount of money and I have to make sure that maximum impression happens. Now, TV is purely impression, no engagement. So, maximum impression happens and I also maximize my cost, minimize my cost. So, this is something that is the problem that I have right now. Check the data set. The data set has 9 shows A1 to A9. And these are the number of ads that you give on those shows. So, this is something is the decision variable. This is something is the decision variable. You decide later point of time how much ads to give, how much ads not to give. And this is the per 30-second cost of those ads. So, each ad will cost $32. So, then what is the total cost? The total cost is nothing but sum product of B6 to B14 then into C6 to C14. This cost is something that you try to minimize. Now, what else is given? For every program, you know that what is the demographic profile. So, the demographic profile of all the observers of that particular channel, let us say these are various programs in one single channel. So, if you have more complex data where you have profiles for different channels, then this particular same problem can be a little bit more difficult and we can deal it with R rather than Excel. But right now I am giving you a simple formula, simple problem and simple solution. So, where all these program watchers are from the same this thing, and this is women 18 to 30 years old, women 31 to 40 years old, 41 to 50 years old, higher than 50 years old, and hit the same thing for men. And these many people, these many millions of people are there in each of the segment. So, 20 million people are there in this segment, 23 million in this segment in USA, let us say. That is the I would say demographic profile. Now, out of these 20 million people, 6% watches this particular, 6% in this particular segment also watches A1 program, 6% this group watches A1 program and 5% watches. On the other hand, 2112, this is the percentage for male. So, this particular program I can say that it is a female dominated program. In an average, female watches 5 to 6%, male watches 1 to 2%. On the other hand, let us say this one is 3564 and then 4443, more or less both cases it is same. On the other hand, there are certain products I can practically say that for example, this one everybody watches, the popular, very popular. This is further more popular, everybody watches this, 30% watches this, 19%, 18%, and that is why based on the popularity the price is also high, very high. On the other hand, I can show you certain ones where let us say this one, this is probably a male preferred kind of a program where male watches 15%, 14%, but women does not watch as much. So, this is the demographic profile of the audience. Now, if I give basically 4 ads here, then what will be the level of exposure? The level of exposure is for each ad, it is sum product of B6 to B14. What is B6 to B14? B6 to B14 is this column, comma D6 to D14, that means this ads into D4. So, let us say I have given 4 ads. Okay. So, I have given 4 ads in A1, that means 0.06% of this 20 million people has seen 4 times. 3% of this 20 million people has seen 1 times. 5% of this 20 million people have not seen. 1% of 20 million people have seen 2 times, and so on. That means, this column into this column into this value is the total number of exposure for people who are women in 18 to 30 years old. That means, in this segment. So, that thing is written here, D4 into sum product of B6 to B14 comma D6 to D14. And the same thing I have dragged it up. So, B6 to B14 remains constant even when I drag. So, I have put F4 signs here, and then for each of them it is like that, E4 into sum product B6 to B14 comma E6 to E14. Similarly, here it is sum product B6 to B14 I6 to I14 into I4 and so on. Now, these are my exposures, and somebody told that this is my goal, this many exposure I have to reach at least. So, currently based on the values I am reaching all the exposures, but I am overshooting the exposure limits. So, let us say here if I write 5, here if I write 10, then I am practically overshooting the exposure limits. My cost is very high, I have to optimize this. How do I optimize this? I go to data, solver, see the objective function is B19, this particular cell, which I try to minimize by changing B6 to B14, fair enough. Now, what are these things? One is B6 to B14 has to be integer, then B6 to B14 has to be between 0 and 20. I have taken the upper limit and lower limit because it is integer. I have to put, there is an integer programming, I have to put upper limit and lower limit. And D15 to K15, that means basically these values, exposure values has to be higher than D17 to K17, that means the goals values. The exposure values has to be higher than the goal values. I select the method as evolutionary and I try to solve it. And it is trying to solve it, already I have reached 3222, and I will actually wait for some time to let it solve and see how it goes. So, what it does? It will again change these values, the values which are in yellow cells, and try to find out what is the maximum lowest cost. So, 3216 is something that I have already reached, and let us say whether if I will wait for 1 more minute and see that whether I can reach further lower level or not. Now, if by chance the demographic profiles were different, let us say this is if these are all from the, so okay. Okay, so that gave me the ads. So, this is the ads that I got. So, give all lots of ads here and do not give ads in other places, and you are getting some amount of exposures. And if you run one more time, it might give you some other result, but more or less your cost will be similar. So, that is now if the demographic profiles are different, if the demographic profiles for different channels are different or different countries are different, then you have to bring in those kind of complexities in the modeling also. But effectively what you have to do? You have to put the values, number of ads you want to put in various channels or various programs in various channels, find out how much is your final exposure, goal exposure, whether the final exposure is higher than the goal exposure, minimize your cost and then change that thing. So, you can do all of this stuff in a function as we did in the last video also. It might be a little bit difficult in coding, but if you have a coder in hand, or in often case marketing analytics professionals will have some entry level data scientists in their hand. So, if you can put them, they will be creating that, or if you know a basic level of coding, but we have learnt in this particular course, you can do it on your own as well. Now, comes the quadratic part. So, let us say I am saying that the two level of complexities I am bringing in. I am saying that the cost for one ad is whatever I told you before, but for two ads it is not a linear. So, if I just try to plot this, you see that they are slowly coming down, the marginal rate of increase is probably negative. So, this is something, it is slowly S curve type, the sales, there is economies of scale, the more you give ad, the less per unit cost is there. That is why you might want to give more ads, and this I am keeping it between 1 to 10. I do not have data more than 10. So, this is the cost that has been given to me. Same problem, exactly everything remains same. Another thing that I bring in is a penalty. So, I am not saying that the exposure always hardcore it has to meet the goals. Your exposure can be a little bit, this is your exposure, lower than the goals, but if that is the case, then you will have your penalty is that much. So, if you check here, so here this value is basically if D15 is greater than D17, if D15 is greater than C17, then there is no penalty, otherwise the difference will be put here. And then the total penalty value is, okay, so I will just change these values little bit. I will copy these values and paste it here. Okay, so 0 is not allowed probably. Okay, 16 is also not allowed, 1 to 10. One ad has to be given, and so on. So, this I will change actually. So, then so let us say these are the starting values, and so then this is what I have actually is my penalty, and then corresponding for each missing 1000 rupees will be charged. So, that is your penalty. So, then the total cost is the cost that you incur for giving the ad plus the penalty, that is your target, and this is something that you have to minimize. So, this is what we are saying, that your ending is not hard and fast. The number you might want to, let us say, not achieve the required exposure in one particular segment, that is okay, but you will have some penalty. If you are okay to take that penalty, it is not an issue, but if you are not okay to take that penalty, then you have to reach the goal for each of these segments. Now, here I have done a little bit wrong. What I have done is I have written H lookup B6 means this value into C2 to L14. H lookup means first. So, B6 it will actually find out in this first column how many first row basically. If in this case it is 1, so it will find out in this column. If in next case it is 10, so it will find out in this column, and so on. So, H lookup means row wise finding out, then from which row it will pick up the value L6 plus 1. So, L6 is the first guy. So, it is for A1. So, that is why it is 1. 1 plus 1 comes up to be 2, that means from the second row you will get the value here. For this case, let us say this is 10, B13 is 10. So, then this particular column is what you find out, and L13 is 8, 8 plus 1 is 9. So, that means you are trying to find out from the 9th row. So, 10 matching happened, then 1, 2, 3, 4, 5, 6, 7, 8, 9. The value should come up to be, okay, so not 9, wait a minute. Yeah, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, the value that should come up to be 1700, and 1700 is the value that is being shown here. So, that is, but by chance if this ad is 0, then you have to take the cost to be 0, that I forgot to take. So, if this is greater than 0, then only this applies, otherwise the cost is 0. Okay. So, that is something that I have written. Fair enough. Now, if it is 0, then no issues, it is 0, fair enough, it is working. So, now my job is to minimize this target value. So, what do? I go to data, solver, minimize B21 by changing B6 to B14. Same thing, these guys should be between 0 to 10 and integer. Fair enough, evolutionary. So, I try to solve it. Already it got dropped to, okay. So, I will continue a little bit more, 3217 to 3192. I will continue further. Let us say if it further drops or not. I have reached to 3172, 3147. So, it is running right now, and I can probably stop at a later point in time. It has come down pretty good, 3087 or something, 3087, see. And if I further continue a little bit more, let us see any other cases where it can further reduce. So, no, 3087 till now I am not seeing anything very lower than that. So, I will stop here, fair enough. So, okay. So, now if that is the solution, see 10, 10, 10, 0 for this one, 0 for this one and some values, I am getting the cost as 3087 and there is no penalty. So, that is how you can deal with the penalty values also, and you can find out that in for which kind of products how much money to put. And you can check for other models also. For example, let us say, so here we are assumed all these things are the add effects. Here the impression is the only thing, we are not considered the sales, but we can also consider sales. Let us say I say that this is impression, but in this group impression 100 impression will lead to 5% sales and 5 sales, and here 90% will lead to 12 sales, let us say. So, then correspondingly I can find out that how much is the exposure, how much is the sales, and I can say that okay, let us optimize sales rather than optimize price or reduce cost or something like that. So, I can make this whatever based on my objective functions, I can make things whatever level of complexity I want to bring in, and based on that I can find out that where I want to put how much money, so that all my goals and etc. that I have in my life while doing advertisement modeling works fine. So, that is all for advertisement modeling. In the next week, we will come up with a very interesting topic called retail level analytics, retail level marketing analytics, and we will start with recommendation engine and then we will do market basket analysis. These are the two topics which are very interesting, and we will deal with that in the next week. Thank you very much for being with me, and I will see you in the next week.